purpose of this video is on exponent rules, more so a quick review and then a larger focus on examples. The first the first rule I want to talk about is the product rule. So you can see here through properties, it's listed as x to the m times x to the n, and essentially the biggest thing you need to know is that you're adding those exponents. So I tried to show that in two ways down here. So in one way, I'm showing it where you're actually using the property, right? So you're taking the base and you're adding the exponents and getting x to the 8th. But remember yesterday we talked about how you can absolutely expand, right? So if you want to take x to the 5th and write it out as 5x's, and you want to take x to the 3rd and write it out as 3x's, and then count, you end with the same answer. For the quotient rule, quotient means to divide. This means division. For the quotient rule, essentially the property is that you subtract. Okay, so you take the numerator power and subtract the denominator power. So in this example here, if I use the property, I did 7 minus 3 to get x to the 4th. Notice that the base does not change. It's still x. If you do not use the property, if you are using just expansion, you can see that I wrote 7 x's on the top and 3 on the bottom. And then I found the groupings that when divided make 1, because x divided by x is 1. So when I divided all of these, those wipe out because they become 1. I'm left with 4 x's, which matches the x to the 4th. The last property is the power property. And remember, that's when there's a power on the inside and then there's a power on the outside. And when that's the case, you multiply the two exponents. So again, I showed it below here. Here's my example, and I showed it by property. So I would multiply the two exponents and get x to the 12th. If you are not a fan of that, again, just showing you the other way, I expanded the inside. And then I just want to note a reminder, I talked about this yesterday, but that 6 represents how many sets of parentheses there are. So you can see then here on the right, I then wrote 6 sets of those two, and when you count, you get x to the 12th. So that's just a quick rundown or review of the properties that were talked about yesterday. So I wanted to go through some examples by property, and I starred some trickier ones that we didn't really get to go through yesterday. So in this first one, you can see there's a to the 6 times a. If you're wondering, like, well, what exponent would be on that a, there's a 1. If it's written, it has to be a 1. So now, if I use expansion, I would write 6 a's first and then times another a, which is a to the 7th, which does work because if I use the property, 6 plus 1 is 7, so that's how that worked out. Again, if I use expansion, I've got 2 t's times 3 t's times 5 t's. So in terms of how many total t's are there are 10. And again, I can get that by thinking t to the 2 plus 3 plus 5 power, which again is 10. In this case, with the 4s, you can expand with 3 4s and then 8 4s. And if you count them, there are 11 total 4s. Again, you could get that by using the property as well. When we get down to 4 and 5, the more challenging ones, I want to expand these so I can show you how you would go about this. So this first one, I want to be clear that this third power is only on a. If it were going to both of them, it would have had to use a parenthesis to show that both a and 6 are getting the 3. It does not have a parenthesis, though, in this example. So the exponent 3, is only on the a. So this expands to a 6 with 3 a's times a 5 with 4 a's. So if we follow our operation, I'm still going to do 6 times 5, which is 30, and then I'm going to count my a's, which is 7. So that's how that works. Okay, so be careful to not add the coefficients because you're adding the exponents. Those two things don't go hand in hand. Same thing on 5. I have a 7 with 2 x's, and then I have 5 x's. If you want a coefficient there, it would be a 1. And if I multiply that, I would multiply the 7 and the 1 and get 7, count my x's, and I have 7 x's. So that would be my simplified expression there. If we move to quotient, remember division. In this case, I would have 6 t's on the top and 2 t's on the bottom. And when I go to find my partners of 1, I'm left with t to the 4th, which I could have gotten by t to the 6 minus 2, which is t to the 4th as well. The second one I put in here because I definitely think it ties to some stuff we were trying to do yesterday. So there's t, and then there are 4 t's on the bottom. So again, if I try to find the 1 partners, it's there. And and I have 3 t's left, but they're in the denominator. So it would look like this. Remember, if the numerator empties out, there is a 1 there. So this would be my final expression. You could have gotten that by having t to the 1 minus 4, which is t to the negative 3. And remember, we talked yesterday that anything to a negative power means to move it to the denominator. So these two things kind of mean the same thing. This third one is a tricky one because I have a lot of students that want to try to like wipe out these 3's, and then I'll get something like 1 to the 5th. But that's not how this works because we're not actually canceling out anything like that. So I'm going to go ahead and expand this just like I have been. I think there's 7 there. And then there's 2 on the bottom. So you're still trying to remember or think about how many 3's. So here's a partner of 1, here's a partner of 1. So there are 5 3's. Okay, so and again, you could have gotten that by thinking 3 to the 7 minus 2 if you want to use the property. On 4 and 5, expanding these, you would have 10 with 5 m's on it over 5 with 9 m's. Okay, so you treat the m's the same way we have been, right? So here's a partner of 1, 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 leaving me with m to the 4th in the denominator, okay? And when you think about 10 fifths, I want you to think about reducing it. So 10 fifths, I can take out a 5 from both of those, and that becomes a 1, and this becomes a 2. So this actually simplifies to 2 over m to the 4th. And it makes sense that the 2 is in the numerator because the larger number was on the top, the 10. On number 5, I'm going to expand the same way I have above. So a 3 with 5 x's and 27 with 1x. And again, I'm going to look for the partners. So right here is a partner of 1. So I'm going to have x to the 4th in the numerator. And then again, if I think about reducing 3 27ths, this 3 becomes a 1, and this 27 becomes a 9. So this would be my final simplified form. Last but not least is the power product. And remember, the power product is where you, if you want to use the property, you multiply. But really that outside exponent is how many sets. So if I think about this, I've got 4 x's in the inside, and I've got 2 sets of those. So this gives me that x to the 8th, okay, which I could have gotten by doing x to the 4th, or excuse me, yeah, times 2, that was right, sorry. For the second one, I'm not going to write this all out because that would be a lot of them, but remember, I would have like 8 z's here, and then I'd have another 8, another 8, another 8, another 8. So I have 5 sets of 8. 5 sets of 8. So that is z to the 40th. And you are absolutely able to fill that out if you want to. I'm not overly excited about writing 40 z's. And then for the third one, I have 2 7s, and then I have 3 sets of them. So I have 7 to the 6th. Number 4 and 5, these were some tricky ones yesterday, specifically in the Desmos lesson. So I'm going to write out the inside. So there's my first parenthesis, and then I have 4 sets of those. Once you write this out, it's kind of nice because it becomes the first property, the product property. So essentially, I am multiplying all the 3's, and then I count my y's, and I have 12. So if I can figure out what 3 times 3 times 3 times 3 is, which you can in any calculator, this simplifies to 81 y to the 12th, okay? So writing it out, and I'm going to point out the very biggest misconception here is that students usually do 3 times 4 y to the 12th. So they'll give me 12y to the 12th. And that's not what that means. There are 4 sets of 3y to the 3rd. So this is no good. Don't do that. All right, this last one, I have negative 3x, or negative 3 with 3 x's. And I have that 2 times. I have 2 sets of them. So I'm going to do negative 3 times negative 3, and then I have x to the 6. So this ends up being 9x to the 6. And it's positive because remember that 2 negatives make a positive. That's it for this video. I'm hoping that going through some more examples helps you to be successful on the next steps while you're at home. If you have any questions, you can absolutely send me a message or an email, and I would be happy to help.